Now I change my hat again, and I change also the microphone. So the next presentation is with two persons, so it's a double presentation from Madame Oufa and Madame Brahim from Serist in Algeria. They will speak about Abinit application. Madame Oufa.
My presentation will talk about Abinit as a first step on grid infrastructure and the Reds project. My presentation contains two parts. The first part that I will present to you, and the second part will be presented by Mr. Lagoon. So the first part, it's talk about the Abinit as code that has been deployed on the grid infrastructure using the Science Gateway. This achievement has been done under Reds project. So we have implemented our Science Gateway, Algerian Science Gateway. Our portal gives another way to use applications to the large communities of scientific researchers in some science domain. In the case of Abinit, is under the materials science domain. So the Science Gateway offers an interface that provides tools to users to submit their application, to use the Science Gateway to submit their application to the grid infrastructure and hide the complexity of the middleware and of the grid. So, it change the way of the infrastructure they are used. Before using the Science Gateway, users, in order to use the grid infrastructure, they use command line. So this allows many users very far to use the grid because they have to cope with complex security procedure, execution script, job description language, and command line. So all this thing makes the learning curve very steep and keeps no expert away. That's why we are using now this portal. So our Science Gateway portal based on life-ray technologies with Catania Science Gateway framework using the grid engine. The authorization is based on the identity provider. It belongs to the GREDP Federation. The authentication is based on LDAP. We have deployed many applications that has been developed by ENF and Catania team. These applications are Octave, GROMACS, AIR, and Abinit. So here you can see the portlet that has been developed and deployed onto our Science Gateway. So the customization of the portlet, it's we have integrated the both mode, sequential and parallel. And the execution works well with demo and real analysis. So you can see here the portlet developed. So that allow to the user can use the both modes, sequential and parallel, can use the number of cores that he's used in his code, and after you can include inputs files. And finally, he can submit his application to the infrastructure. In the Science Gateway, we have added also the tools that allow to users to monitor their job, their application. So he can find the list of all applications submitted to the infrastructure, and he can get his output after the execution. So this briefly my presentation that has been done. So now I will allow Mr. Lagoon to present the use case of Abinit on our infrastructure.
I'm Lagoon Brahim from Lagouat University in Algeria. I will to thank CIRIST and ANFN to the collaboration to develop the portlet. Well, the Abinit application is it's in code for material science. Material science is very important area of research because we have always needed of new materials with high performance properties. There is three different disciplines in the material science: the experimental, the theory, and the simulation. The simulation at the atomic scale, there is three different methods. One of the important methods is the density functional theory. The historical of this theory is summarized in the next. The Thomas Fermi model in 20s, the paper of Homberg Cohen on and the paper of Cohen-Sham in 16s. The use of LDR, local density approximation, in 70s and 80s. The dynamic molecular with DFT, the Carl-Parino methods in 85. Other functional of exchange and correlation used by chemistry in 88. The modern theory of polarization in 94. The density functional perturbation theory in 19. The recent study of the static